Hi students, in this video we are going to discuss binary search tree search operation implementation in C. So consider an example of binary search tree. Suppose 25, 20, 50. Already this video I explained with an example. So please watch that video. In this video just I am recollecting the things. Then we will move on to program. Okay. So now I want to search for 50. I want to search for 50. How to search? So first compare 25 and element to be searched. Okay. As 50 is greater than 25, move on to right subtree. Now compare 50 and 50. Yes, both are equal. Return this node. That means element is present, then successful search. Element is not present, that is unsuccessful search. This is the main logic involved in search operation. Now how to write the code. Now for this, already in the previous video I explained how to construct a binary search tree by using insertion operation implementation. So this program explanation please see in the previous video. Then just see this is search code. Okay. So now what is this? So structure of a node creation and insertion function. This is in order tree traversal. This is pre-order tree traversal, post-order tree traversal. In main function we created a binary search tree with the 4 nodes and 3 traversals we have called. So now what we are going to discuss is search operation. Now tree is already there. Now in that tree we want to perform search operation. How to do this? So search operation on binary search tree. Okay. So now here I am writing binary search tree. Now if tree is there, then search for the element and return. So if tree is not there or the element is not present, then return null. So it returns a node. So struct BST underscore node search of, again struct BST underscore node of star PTR and element to be search. So if PTR equal to null, then there are no elements, so simply return null. If tree is empty, then simply return null. Now else if element is less than PTR of data, then we have to move on to left subtree. That's why return recursive call it is also. There's a search function also we are writing by using recursion. Search of, if element is less, then move on to left subtree. That's why I'm writing like this. Suppose the element may be greater. So else if element is greater than PTR of data, then return search of PTR of right comma element. Okay. So it is less, then move on to left subtree. If it is greater, then move on to right subtree. This is not satisfied, this is not satisfied. Then what does it mean? Element is equal to PTR's data. Then what shall we do? Simply else return PTR. That's it. Search operation. Okay. So now we have to call the search function, whether that element is present or not. So now call the function like see here already I declared struct search node. So now I declared a search node. Now search node equal to search of PTR comma which element we want to search, for example 35. Okay. So now we will check whether element is present or not. If search node equal to null, then printf element is not present, null, it is null na, so element is not present, else printf element is present in the BST. Okay, so just we will write this in the new line for differentiation purpose. Okay, save this program, then compile. Null spelling is wrong, so null, null. Execute, compile. So again, if ptr equal to null, it is returning null. Save, execute, compile. So now here we got colon, now it is a semicolon. Save it, compile and run. Again it is showing return null. So now here have to put star, save it, compile. You see, element is present in the binary search tree. Which element we want to search? 35. Yes, 35 is there. That's why it is giving the output as element is present in the binary search tree. If element is not there, na, suppose I am giving 350. Now execute it. See, element is not present. Like that, you can perform search operation in the binary search tree. Hope you understand, students. So if you like the video, please share with your friends. If you have any doubt, please post the message in the comment box. Thank you, students. Have a great day. Bye.